These people did not take into account their new coefficient of friction because of the rain, and therefore their momentum was conserved in a collision.
What do you know about physics?
I know a lot about physics.
Like what?
I know that there are nuclei and atoms. And
Chemistry.
that's chemistry?
Yeah.
And biology.
And biology.
We start over.
Mr. Ayers, what do you know about physics?
I know about planets and stars.
Okay, that's
What about them?
I know that planets orbit stars
Do you know why?
because of their gravity. Stars have massive gravity, and if there's lots of gravity, they can become a black hole. And even light can't escape.
Okay, good.
Do you want to give us an example of physics in your everyday life?
Sure. Sometimes my pen falls down, and gravity pulls it to the ground, and I'm like, oh, physics!
Would you like to explain the physics of kickball to me or projectile motion?
ball, excuse you. Well, if you kick it at a 45-degree angle, you'll get the largest horizontal displacement.
That's true.
Fun fact.
Yep.
However, it's probably also really easy to catch out if you kick it at a 45-degree angle.
So aim for their heads. That'll be hard.
And horizontal velocity is constant because there's no horizontal acceleration.
Oh, that was nice.
And you have to do it in the horizontal and the vertical planes, like independently, because they function independently of each other. So when Emily kicks the ball, she is exerting a force that is at an angle, and so you have to break it down into its horizontal and vertical components. And then you can solve for how high it goes, how fast it goes, and how far it goes.
Oh god, I missed that
Okay, so when Ferris kicked the ball, there was a force that he exerted on the ball, but the ball exerted the same force back on his leg. Equal and opposite forces.
one. When Emily pitches the ball, because of the friction on the ground, does not slide, it rotates. So it has rotational energy.
Indeed.
Yep. Didn't do that well on that part of the AP exam.
Okay, so the inertia of something is its like resistance to change in momentum. So if you're running really fast, watch my Tillman. Ready? Good example, but he was running really fast and he got to first base so he could stop. But the thing is, he was running so fast that he couldn't stop, so he had too much inertia, so he had to keep running until he could slow down.
Real life physics. Friction.
I'm doing work on the hole puncher because I'm moving it opposite to the force that is acting against it. Yay, real life physics.
Mrs. K is unamused. Or very
amused.
Physics. It's in your everyday life. Do you know this, Mrs. K?
I do, but I teach theater, so I ignore science as much as possible.
Really? Because your swivel chair right here, this is like rotational something. Probably.
Wow, that's profound. Rotational something.
You forgot the probably.
Matt is spinning, and John is spinning, and so his rotational inertia is large because his mass is distributed far away from his center of rotation, axis of rotation, and then when Matt brings his arms in, because his momentum is the same, he spins faster because now his mass is distributed closer to his axis of rotation, so his angular velocity is faster.
Let's explain why Matt fell down.
I'm gonna go with dizzy.
Alright, I'm going to try and open this door, and in order to do so, I'm going to have to exert a torque. Oh no! I can't open the door! It's probably because my force is not far enough away from the pivot point. Because if I exert the force along a larger radius, my torque is larger.
Oh.
Open the door!
Okay, when I'm running and I stop, I slide because I'm a body in motion and I stay in motion. And I stop because of friction, because this is a non-ideal environment. Physics.
Alright, now we're going to do the physics of hugs, alright? Now running hugs are perfectly inelastic collisions because we have two masses, each with an initial velocity. In this case, I'll be at rest and she will start running. And then the two masses collide and they stick together and they continue moving, this time with a smaller velocity because momentum is conserved. So an example of a perfectly inelastic collision through hugging. Oh god. Oh no, oh no.
Hey, Mr. Cronin, what do you know about physics?
I know that F equals ma. I know that if you drop something, gravity will pull it to the ground or wherever. I know that I was really bad at it, and I got a 0 on my college final exam for physics, and that I haven't taken it since 1986. How's this? F equals ma, force equals mass times acceleration. Stand still. If I throw it, if I just roll it, it's not really going to do much because there's no acceleration. However, with the same mass, if I really haul back,
It's a projectile then.
catch it. See how much faster that went that way?
It's a projectile.
We're on two different parts of the carousel, but we're moving at the same speed. So clearly, although we have the same angular velocity, my velocity, since I am farther out and therefore my radius is larger than Matt's. That's what I said. My linear velocity, but we have the same angular velocity, which is currently decreasing as the ride is coming to an end.
There are two separate locations.
Woo! Real life physics! Ramon, what do you know about physics?
Object at rest tends to stay at rest. Object at motion tends to stay in motion.
Awesome. Do you know what that concept is called?
No.
Okay.
Could you wait?
Newton's third law of motion.
Could you apply it to life?
What?
Could you apply it to life?
Absolutely.
Could you do it now?
Yes.
Okay, show us.
I'm stuck in this job. I'll stay in this job until I die.
Alright, so as you can see, my friends here are jumping on the trampoline. Now they're able to do this for a couple of reasons. The first is energy. When they're at the top, all of their energy is gravitational potential energy. But when they jump down into the trampoline, at the very bottom all they have is potential spring energy. And that's because they are launched back up because the trampoline exerts a force equal to kx, where x is the distance that they are displaced, and k is the spring constant. So it exerts a force, and they're rocketed back up to the top of their potential energy, and then they fall back down. Physics!
Real life physics! Dogs have physics too!